Hello everyone and welcome back. In today's episode, I want to show you how to set up a bare metal Kubernetes cluster running Deepseek. And we're going to use some of the common components you might be used to, like Ollama for our interface. This isn't going to be 100% production ready because we're not going to have things like persistent volumes. We're just going to get this running bare minimum to show you what's required to run any GPU workload inside of Kubernetes and doing it with bare metal, because we're going to capitalize on owning our hardware and making sure that we're not renting really expensive GPUs in a cloud provider. So to get started, go ahead and grab a GPU somewhere and plug it into a machine and let's get going. Now, of course, if you're on this channel, you know that we're going to use Talos Linux to get the cluster started, and I'm going to go the easy route and use Omni. All of these patches and commands that I show, you can use with just straight Talos. You can call the API and use Talos control, but I'm going to do it all with Omni because A, it's just easier to show the steps and to configure the patches and stuff without running each command. So the first thing you're going to want to do, of course, is getting started. Sign up for an Omni account. You get 2 weeks free trial. You can run it yourself in a home lab environment, non-production. But yeah, the SaaS is the easiest way to get started. Download the installation media. I'm going to go with the generic installation media and not apply any extensions or patches to it yet because I want to show you each of those steps one by one. So we're going to drop this down and grab our ISO. I have an AMD 64 machine, and then grab the latest version of Talos, whatever you want to get. So click the download and that will generate and save an ISO for me. Now go ahead and copy that ISO to a USB drive with DD or use Ventoy or something, boot the machine, and it should connect into Omni. And you can see here, I have a machine connected. It's actually on this monitor here behind me. So you might see it scroll as it's booted, but that's generally what you want to do first. We just have an ISO booted, it's connected to Omni. Now let's create a cluster. Go over here into clusters and then click create cluster. I'm going to name this AI because why not? I'm just going to select an older version of Talos so we can show an upgrade process as well. And I'll pick the latest version of Kubernetes. And again, I'm not doing any patches or extensions at this point. You could if you wanted to, but I'm not going to do the GPU patches, at least that I would need. So we're going to say this is a control plane node. The installation media is already selected. And I'm going to click this little gear here and apply a patch just to get a name on it. I just don't want a randomly generated host name. So we'll call it GPU. So let's create that cluster first. It will automatically ask me if I want to untaint this control plane node so it can run workloads as well. I'm going to click yes on that because I don't have dedicated worker nodes in this cluster. If you have control plane set up and you want dedicated GPU workers, you wouldn't need this patch necessarily. But again, I only have a single node in this cluster. So we're going to let that install happen as it provisions Kubernetes and Talos onto this machine. So it took a couple minutes and Kubernetes is up and running on this node. And the first thing I want to do just to show how to do it is I'm going to download my Talos config and my kube config over here on the right. So I can get both those files and we will put them in the right places. That's going to be your .talos/config file. You also could put it wherever you want and just export the variable. That's what I typically do. I like to have separate Talos config files. So we're going to go ahead and do that. Jump over here to the terminal. And let's just see the dashboard on it, right? Like the normal things you might do with Talos control is dashboard, and that node name is GPU. In this case, because I'm using Omni, I don't need an endpoint. I don't have like a dedicated endpoint because Omni is my endpoint. So you can leave that side of it off. And I can see here the machine is up and running. The normal things I would do with Talos control on a standard machine. And this is just showing that you can do all these things with vanilla Talos. The next thing I want to do is I actually just want to see what GPU I have on this device. And so for that, you can get PCI devices. So if we get the PCI devices on that node, I'm just going to pipe it to less so it's a little less messy as it outputs. And we can see here all the PCI devices. That's my device C. Again, we have an API. We know this is structured data. This is like LSPCI, but I don't have to grep it. I don't have to do all the funny things that I've always had to do traditionally. So let's find, I see an NVIDIA device here. And so I have a display controller and a multimedia controller. That device shows up as multiple things. I want the display controller, which is this device right here. So I can see this is the ID for that device. And now I can get the actual device and I can see my things like my subclass, my vendor ID, and it's a a GeForce GTX 1070. It's a graphics card that I had that I just plugged into this machine to do this demo. So that's all we need to know. We actually don't need this information. I just want to know I have a GPU attached to it. It's an NVIDIA card. And now let's go ahead and install the extensions in order to make that work. Back in Omni, we can go over to the GPU device and the last tab here for extensions. And in this case, we're going to go down to update extensions here at the bottom, and I'm going to search for NVIDIA. Now there's a bunch of options here. We have two different branches, which is what NVIDIA publishes. They have an LTS, a long-term support, which is an older, a little more stable driver, and a production version of the driver. The production version is a lot better. It's just more stable across the board, especially on Linux. And if anyone's been following NVIDIA drivers, the 555 driver is actually one of the better NVIDIA drivers, but it's not part of production yet. It's still on the beta branch. And we don't publish beta drivers because those come out really frequently. But I also know that I don't want to use the open GPU kernel modules. I'm going to go ahead and use the non-free production here. And I'm going to use the container toolkits. Those are both pieces that you need for just GPU workloads to run. I need the container toolkits and I need the production driver. And those are going to layer file system into Talos so that those files would be present for me to use for my workloads. So let's go ahead and apply both those extensions. While those are installing, again, this is a single node machine, so it does need to reboot the box. I'm also going to show you how to do it in the image factory. So if you go to go factory.talos.dev, you can do a bare metal machine, select the version of Talos that we want, AMD 64, just like before. I get the same extensions here. So I can search for NVIDIA, and I have the NVIDIA Container Toolkit production and the non-free Kmod production. So I would want both of those extensions. I can click next. Want any customizations, I can add them. And then I have my schematic here. So if I wanted to do a Talos upgrade from the command line with vanilla Talos, I can look down here, and this has an upgrading Talos Linux. This is the image you could use. You could say, hey, upgrade Talos, this is the image I want to use, and that'll put those extensions on the disk for you. And the nice thing about these schematics is this schematic ID is consistent version to version. So if I change my Talos version from 1.8 to 1.9, this schematic is always going to have these official extensions added to it. And so I don't need to worry about what's the schematic for the next upgraded Talos with those extensions. The schematic ID stays the same. Rolling upgrades is going to be consistent and easy to do. But if you're running vanilla Talos, do it through Image Factory. If you're doing it through Omni, it's integrated into the UI. Let's go back here into my cluster, and I see that machine is booting now. And so if we click on it, we will see down here on the main page, services running. And I have this new NVIDIA service that's running, and it's waiting for configuration. So it's just waiting. Everything else is running, but that service says like, hey, actually I'm not ready yet because I don't know what to do. And to actually apply this and make that service healthy, I need to add some patches. And I'm going to do this in 2 stages, even though I could do it all together. The first patch is going to be just the kernel modules. I have drivers on disk, but I never told the kernel load those drivers. Use them so that the GPU can actually be functional. So I need this patch right here in order to load the modules into the system. So inside Omni on the machine itself, I can go to the Patches tab, create a patch. I'm going to call this NVIDIA modules. Paste that in, and that's going to apply the patch for the kernel modules. The other patch I'm going to apply is I'm going to make the default runtime use NVIDIA. You can have multiple runtimes on a node, and you can switch them with runtime classes in Kubernetes. All of those things get a little more complicated the more configuration you add. In this case, I have a single node, I have a single GPU. I'm just going to say, let's run everything under the NVIDIA runtime and not worry about how we're switching that. Again, in a production environment, you might want to have like isolated nodes that only run GPU workloads, so you can utilize more of the GPUs. But for me, I don't actually need that. I'm just doing this on a single node. Come back in here to Omni again and configure that patch. And all this patch is really doing is adding a file on the disk to tell containerd use this as the defaults. So now I have my 2 patches that I need on the system. Now let's try to run a workload. I'm going to use the Ollama Helm charts to get started, and I just created a values file that basically said I have an NVIDIA card, I want it enabled, and I have one of them. So that's the patch for Ollama. I didn't really do anything else outside of the defaults Helm chart. And now I'm going to render a full manifest from the Helm chart. I don't like doing Helm directly into Kubernetes. I usually template it, check that in somewhere. And so I have this template command. Ollama is the name of it, where it's coming from. I'm deploying that to the Ollama namespace, and I'm using my values file, putting it in this chart. I did not yet create the Ollama namespace, so let's go ahead and do that. And Ollama does need privilege to run, so we are setting that label on the namespace so that we don't get complaints about the workload not running. Let's apply the namespace first. And now we can apply the full rendered Ollama chart. And again, we will get some warnings on it because this workload isn't restricted. It's not dropping any capabilities. It's still running as root. All the practices that you probably don't want in your cluster are usually defaults in Helm charts. So just beware of that. If you're trying to ship this to production and you want to reduce some of that, you're going to have to tweak some things. Now let's go ahead and see what's happening in the cluster. We can see this workload is pending. Why? Why is it pending? What's going on here? Let's describe it. We'll see all the way down here at the bottom, 0 of 1 nodes are available, insufficient GPUs. But I have a GPU. Why is the machine doesn't have a GPU? Let's look at the node itself. Get the node, output YAML, pipe it to less. And let's look for the capacity. So here we see we have what's allocatable and our capacity. And our capacity only has CPU, storage, huge pages, memory, and pods. There's no GPU here. We never told Kubernetes that this node has a GPU. Even though it's functional on the node itself, we actually have to tell the kubelets to create that. And the kubelet by default only looks at these 5 things as what capacity exists. To do that, you have to use device plugins. Device plugins is how the kubelet knows about other devices, other things that can become capacity. And this is traditionally how you create GPU capacity on your node. There are a bunch of different device plugins. If you look at the examples here, everything from AMD and Intel specific things on the chips themselves, NVIDIA things, and other storage and networking devices. All of these can become capacity. Today in Kubernetes, this is how you do it with device plugins. In the future, there's probably going to be some other way of doing it. But for now, what these device plugins do is they run as a daemon set and they talk to the kubelet over the local gRPC API and they send it some information. And they say, hey, I have this capacity. I know what this thing is. It's a piece of hardware. I can read the PCI device and I know if it's healthy or not. So I'm going to tell you it's here and it's available. Lots of people will jump directly to the NVIDIA GPU operator. Now this operator does a lot of things. It basically does all the steps we've been doing up to this point. It will run as a daemon set. It will discover the PCI devices. It will install the drivers, load the kernel modules. It does all of those things on the fly in production. I don't know about you, but I don't prefer doing mod probe on live production systems. And that is exactly what GPU operator does. And I know this is the NVIDIA supported way of getting a generic driver on any host, but it also does not work if the file system is read-only. It doesn't work if the node is more secure. This is a generic traditional Linux way of let's use a package manager and a big run file to install the things we need. Which, as a side note, have you ever looked at the NVIDIA run file? The file itself, a lot of people, it's a binary file, but if you look at it, it's actually a shell scripts. And so if you just open that file, you're just running bash. The whole thing is just a big bash script. And with Talos, we don't like doing that. We don't have bash, we don't have shell, we don't have anything on the system. This is just a different traditional way of doing things. And if you look all the way down near the end of this script, what it actually does is it sets a bunch of flags and then it embeds, where is it? Oh, there it is. An elf binary, like literally just cat binary to the end of this script. And it will extract that from the script itself. That's why the file is so big, is it has these binaries in text representation. So you can literally see in the header of the file that it's an elf binary. So if you just extract that, you will get the modules and the things that are just compiled binaries. But again, at Talos, we don't like doing that. We're not going to make you run this arbitrary bash script, which is essentially curl to bash. We're going to go step by step. We're going to add the extensions. We're going to add the patches. And now we need to tell the kubelets we have capacity. We want to be able to consume that capacity with the workload that we just scheduled. I'm going to run this command with kubectl get node for the GPU, and I'm going to look at status capacity here in the outputs, and VIDI is just like a modern watch. So it's going to keep requesting information from that node and get me that capacity. Over here, I'm going to apply the device plugin. The NVIDIA device plugin is the component that health checks the hardware on the system and then calls the Kubernetes, the kubelet API. So it doesn't do all of the things that the operator does. It's just doing that base level, let's add capacity to the node. And real quick, let's also look at the pods. Get pods in the namespace Ollama. It's still pending. And I can see here that I already got the NVIDIA GPU popped into the node as having capacity, and immediately my container on the other side is now creating. And now if we look at the logs for the Ollama container, we can actually see here that it detected and is using that video card. It said, oh, I have a GPU, I have a NVIDIA card, I'm gonna go ahead and start using that. So Ollama is gonna use that card for its models. And now I can see I have Ollama running. It finished pulling. I didn't pre-pull any images on it, or any models on it. So over here, I'm going to go ahead and port forward the service Ollama, which is in the Ollama namespace, and there's an HTTP port that is exposing Ollama to the rest of the network. Again, not production quality here. You could do a load balancer, you could do Ingress, you could do a lot of things to route traffic to an Ollama endpoint. You could use one of the many web interfaces for a chatbot, those sorts of things. I'm just going to port forward to show you that it's going to work. And in this case, it's port forwarding to my local host on the default Ollama port. So that's going to show it working there. And then I can just run Ollama. And of course, I'm going to try the Deepseek R1, and let's get the smaller version, the 1.5B, which is only like a gig in size. And now we're pulling that manifest. And so this is going to pull that model onto the machine. It's downloading it from the Ollama registry and allowing me to then run commands against it. Again, this is not production quality because if I ever had to reschedule the pod or do something else, the data's gone. This model would have to be pulled every time. And we can ask it a question and see that we're actually getting pretty fast outputs on that GPU, even though the GPU is not really big or fancy or anything. I bought it used on OfferUp. So it's not like spending a bunch of money. I think I paid maybe $100 for it. And that just shows that we can go all the way from a bare metal server that had nothing installed on it to a Ollama running with a model in, I don't know, how long is this video? And I didn't have to pre-configure anything. I don't rent this now. This literally just runs at my house. I own it. I can do whatever I want. I can pull more models. I can run whatever GPU workloads I want. If you're doing this with something like VMs or a virtual GPU, you're going to have to load virtual GPU drivers inside of the VM, inside of Talos, to divvy up the larger GPU into smaller pieces, and then each VM can consume parts of it. In this case, I'm doing a one-to-one mapping for GPU to workload on a single node. But there's lots of other improvements, and again, you can do this all with just straight generic Talos, or you can do it with Omni, managing the patches and applying those things for upgrades. Thanks everyone for watching. If you got this far in the video, please leave a comment and let me know which models you're running, how you're running them, and where you're running. What kind of hardware GPUs are you finding work for you? You can experiment with these things without needing to spend a bunch of time researching how to get it set up, or even spending ongoing hundreds of dollars for cloud nodes. Just run it at home, see if you want to use it, experiment at home, and just be responsible about what infrastructure you're running and where you're running it. Thanks everyone. We'll talk to you again next time.